Now that you've seen the general innervation of the gut and the hierarchy of control, let's talk about the topical organization of the autonomic nervous system on the GI tract. And for our visual learners, this is what this is the title. And we see here are two parasympathetic nerves, the vagus nerve and the pelvic nerve. The vagus nerve comes from the brainstem in the medulla, and pelvic nerve comes at the other end near the pelvis, specifically the sacral region. Now, uh, there, it's very simple. The vagus nerve innervates a higher density towards. So here's our. Let me step back. This is our GI tract. This is the esophagus, stomach, intestine, and the colon. And the vagus nerve has a higher density of neurons sending axons down here to the esophagus, closer to the brainstem, which sits on top of the spinal cord. And then it sends out a lower density towards the colon. So the more vagal nerve innervation in the esophagus and stomach, and maybe in the beginning of the intestine, and less so in the later intestine and the colon. The pelvic nerve does only the colon. And then we have, so these are two parasympathetic nervous system, nerves. Now let's talk about sympathetic. Sympathetic nerves equally innervate throughout. They're equal. They innervate everything from the esophagus to the colon. And in general, uh, the sympathetic nerves inhibit motility, and secretion. And it causes vasoconstriction. Vasoconstriction. It causes the smooth muscles around the blood vessels to constrict. So let's think about why that's so. The sympathetic is fight or flight. You're in an emergency situation. You don't want to be digesting your food, and you want to mobilize your body for an emergency. So you want to stop motility. You want to stop digestion and moving food through your system. You want to stop secretion. Again, you're not digesting. You don't want to use your body's resources for the digestive processes. And vasoconstriction, you want to move blood away from your gut. You want to mobilize the blood to other parts of your body that would help you in your fight or flight syndrome. And parasympathetics are the opposite of this. They help in motility, they increase motility and increase secretion, they cause vasodilation. There are two rules, and I should also mention there's a rule of thumb. Let's do a different color. Rule of thumb. If the system activates smooth muscles, it will inhibit sphincters. muscles. It inhibits sphincters. So let's talk about this general organization. Let's connect the dots. So this is a more realistic picture, and we see on this side sympathetic nerves, and we see parasympathetic. How can I tell just by looking at this picture? Well, we see there's one nerve going here, and we see one nerve going down here. There's two nerves here, a higher density and a lower density down going further down. And then, so this has to be a parasympathetic. This is your vagal nerve and the brainstem from the medulla. And here's the pelvic nerves from the sacral levels of S2 to S4. S2 to S4. And here's our sympathetic nerves, and they come from the sympathetic trunk. This is our sympathetic trunk, and they go to three ganglia. The celiac ganglia. Let me get a better color. Something darker or brighter. This is celiac ganglia. There's the superior mesenteric. Ganglia. And then there's the inferior mesenteric. Ganglia. Make the connections to your anatomy. These are all part of your anatomical structures. And that's what they're named for. So we see that this, the parasympathetic supplies all of the gut except for two exceptions. So majority of the gut is smooth muscle. But at the very beginning, at the very top, we see two striatal muscles, not smooth muscles. This is, oops. These are smooth muscles. The striatal muscles are the very beginning of your esophagus, up here are striatal muscles, and your external sphincters at your anus, right down here. These are two striatal muscles that get their innervation from parasympathetic nerves.